Now we're going to continue our talk with the unit circle. Unit circle is the circle that you have that it has all of the conversions between degrees and radians. But specifically, when we say unit circle, that means we're talking about a circle with a radius of one unit. And so then a couple things that are true about this. If I take, let's say, an angle that comes out to here, this angle, if I put this on a coordinate grid, has an xy coordinate point. That xy coordinate point is somewhere less than 1, because if it was 1, then it would be on one of these axes here. And so it's in between those, which is what creates the circle. But those xy points, if I were to drop a perpendicular here, creates a right triangle where this side is y and this side is x. And then the hypotenuse is r, the radius, which is equal to 1. So we know that r is equal to 1 in the unit circle. Well, if we draw an angle in here, and we call that angle theta, then this is what's true about the trig functions in terms of that angle theta. The first thing is that we have the sine value is equal to y over r, the cosine value is equal to x over r, and the tangent value is equal to y over x. And so we end up looking at this in terms of your normal SOHCAHTOA type ideas, where sine is opposite over hypotenuse, y over r, cosine is adjacent over hypotenuse, and tangent where it's opposite over adjacent. Well, we're adding 3 new trig functions in here, and they go along with each of those first 3 that we have. So the 3 new ones that we have are cosecant, which is just the reciprocal of sine. So sine was y over r, cosecant is r over y. Secant, which is the reciprocal of cosine, and cotangent, which is the reciprocal of tangent. And those 6 trig functions are the 6 trig functions we're going to spend the whole year working on. Okay, so you need to know those 6 trig functions. So when it says define or calculate or find these 6 trig functions, those are the 6 we're talking about. The sine, cosine, tangent. Sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Also in this triangle, if we can create or talk about the Pythagorean theorem here. In the right triangle, I've got that the r squared, the hypotenuse, is equal to x squared plus y squared. And if I talk about that and I plug in all of the values that go along this circle, so let's say that I took a number line, and I took a number line and I folded it along the circle. If I take that number line, fold it along the circle, each one of those values have, each one of those points along the circle have a value to them. The ones that we're going to specifically be talking about and spending a lot of time looking at are the ones that are on that unit circle that we had. And so when I take a look at that unit circle, if I look at those values all the way along these points, I've got a ton of different places along this circle that are going to be important for us. And so we're looking in this section at more of being able to use the unit circle and pull things off of the unit circle. And so in order to do that, we need to have the unit circle filled in. So here's purple. That's probably not going to be a good color for us. Here's the first one. So this is square root of 3 over 2, comma 1/2. Here's the second one, square root of 2 over 2, comma square root of 2 over 2. The third one, 1/2, comma square root of 3 over 2. And then all the way up at the top, this is at 0, comma 1. Well, again, if I think about this on the x-axis, this circle is 1 unit long. Okay, and circle is 1 unit long with a radius here of 1. So if I go to the right and I look at this point over here, I'm out 1 on the x-axis, so that's 1 comma 0. I didn't go up at all on the y. But if I look at the 90 degree pi over 2, I'm looking at 0, 1 because I didn't go left or right at all. I just went up on the y-axis. Okay, that's where those values are coming from. They can be figured out. You can figure each one of these out, but I'm giving them to you because they're common ones that are available to us. Now, once you have those 5 things done, you can understand where the rest of these come from. Because at 60 degrees, I've got 1/2 and square root of 3 over 2. Well, over here at 120 degrees, it's the same exact place, except I went left and up instead of right and up. So I went left 1/2 and up square root of 3 over 2. And the same thing with 135 degrees here. I went left square root of 2 over 2 and up the square root of 2 over 2. All right, so we've got, again, looking at common places or common ways to try to remember this. I've got to the left square root of 3 over 2 and up 1/2, and then to the left 1, so that's that -1, and up 0. Then I'm continuing all the way around the circle. I'll do one from the third quadrant here. You go to the left square root of 3 over 2 and down -1/2 to -1/2. And in quadrant 4, I'm going to the right, so all my x's are going to be positive, but I'm going down, and so all my y's are going to be negative, square root of 3 over 2, comma, -1/2. And everything is square root of 3 over 2, 1/2, or square root of 2 over 2, along with the points at the end of a radius at 1, 0, 0, 1, and so on. Okay. So again, another part of this is something that you need to start looking at, trying to memorize and get a better handle on. But what we're doing today is we're actually just looking at that unit circle, and we're trying to find the exact values for the 6 trig functions. Okay. So I've got these 6 trig functions: sine of theta, cosine of theta, tangent of theta. And then with sine goes cosecant, with cosine goes secant, and with tangent goes cotangent. These are the shortcut ways of writing those words. Sine of theta. So the sine of theta, when I look at what I need to do right here, sine of theta is y over r. So I've got r is already equal to 1 because we're in the unit circle, but I need to figure out what y is at pi over 6. So go back to the unit circle here. At pi over 6, I'm here at pi over 6, square root of 3 over 2, comma 1/2, and I want the y value from that. Well, the y value is 1/2. Okay, so I go to fill in my answer, and the y value is 1/2, and the r value was 1, so 1/2 divided by 1 is just 1/2. Cosine, the cosine is x over r. So I go back to the unit circle. I'm still at pi over 6. X in this problem is the square root of 3 over 2. So I have square root of 3 over 2 here over the radius, which is 1. When I divide that by 1, nothing happens to it. So I get square root of 3 over 2. The tangent value is equal to y over x. Well, I have, again, both of those things. Y was 1/2. X was the square root of 3 over 2. Okay. Now here's something that is going to draw you back to some information that we had done before. So I want to leave that there, but I want to try to get a hold of this piece right here. And I'm just going to bring it to a new page, so we can explore this a little bit, what happens with this. So I've got 1/2 over the square root of 3 over 2. Well, when I look at that, I've got a fraction divided by a fraction. And so if I write that this way, 1/2 divided by the square root of 3 over 2, I think some of you might recognize what's going to happen here. So I've got 1/2 divided by, I want to flip and multiply. So I flip the second fraction and change it to multiplying. So when I multiply this, I get the 2's are going to cancel, and I get 1 over the square root of 3. Okay? Think back to Algebra 2, and we're working on this right now in Algebra 2. This is something that carries along the whole way. I cannot leave that square root in the denominator. So in order to get it out of the denominator, I need to multiply by something that will get rid of it. And I make a pair because I'm looking at a square root. So if I multiply by the square root of 3, that on the bottom I have to multiply by the square root of 3 on the top. This is called rationalizing the denominator. So if you're looking it up, trying to find it online, rationalizing the denominator. And on the top I get 1 square root of 3, which is the square root of 3. On the bottom I get the square root of 3 times the square root of 3, which is the square root of 9. If you're remembering back to what happens with that, the square root times the square root of the same number, the square roots cancel out. And so the square root of 9 actually is 3. And so the tangent value actually is the square root of 3 over 3. You can do this long version every single time, or as you start going through, you can rewrite this as the square root of 3 over 3, add this to your unit circle, and know that the outside value is the tangent. Okay, so we've got the cosine, comma, the sine, and then if you want to, you can add the tangent to that. If you add the tangent to that, you have to know that that's the tangent. As I continue along, if I've got that same value, square root of 3 over 2, comma 1/2, and I'm looking for the tangent, this over here at 150 degrees, the square root of 3 over 2, comma 1/2 is going to give me the same exact value, except that I'm in the negative version, and so that's going to give me a negative tangent over there. Down on the bottom, if I have a square root of 3 over 2, comma 1/2 again, I'm going to get a square root of 3 over 3. Two negatives this time in this one are going to give me a positive. And then the same thing happens over here at 330 degrees. Square root of 3 over 2, comma negative 1/2. I end up with the square root of 3 over 3. But one of them is negative, so it's going to end up coming back negative. Okay, so you can kind of go and fill in the tangent portion of this as you continue and go along. I wouldn't go any more than the tangent when you're filling things in there, just because the other 3 trig functions come from being a reciprocal of these. So this was actually equal to the square root of 3 over 3. Now cosecant. You can go back to the original rule and say that it's r over y, but it's a lot easier just to take what you had, all the work that you did for the sine function, and flip it over. So I've got 1/2 for the sine function. If I take the reciprocal of that, I get 2 over 1. If I'm looking at the square root of 3 over 2, I flip that over and I get 2 over the square root of 3. Again, you have the issue of the square root in the denominator. Okay, so you need to go through, multiply both top and bottom by the square root of 3. And I'll show the work on this one. Eventually, I'm not going to show the work. So I get 2 square root of 3 on top and the square root of 9 on the bottom, which is 3. Okay, so I get 2 square root of 3 over 3 for the secant. And the cotangent, again, you end up with the same idea here. 3 over the square root of 3 when I flip it over. I have to multiply by the square root of 3 over the square root of 3, which gives me 3 square roots of 3 over 3. This one actually reduces. The 3's are going to reduce, and so I get the square root of 3. So the cotangent is square root of 3. It's going to be important for you to try, again, there's lots of things that you can find shortcuts in if you don't want to do all the work. There's a shortcut in here. Anytime that you have square root of 3 over 3, it's going to come out to be a cotangent. For the tangent, it's going to come out to be a square root of 3 for the cotangent. Okay, so then we had this for the cosecant here. I'm going to stop this video here because some of you are going to be able to go on without needing the rest of the problems filled in. I will come back and start a new video with the rest of the problems that are going to be filled in here.